Hey, hey, how y'all doing?
Hi, good at yourself?
Woo. Happy, in a lot of ways. But you know what? It's not about me. Exam is today, and I guess what we're doing is this class right now. And um, if I dive in the regular way, is that good by you?
Yes.
Yay. Okay, so here we've got our standard page for the course, and I'm gonna sort of like just go into which is just really so far in terms of week four CD. What I put together is not much because it's no new content today. Yeah, literally, we have the sample exam two questions. Okay, there are built-in answers there, and I want to draw your attention to, in particular, the summer 2023 discussion in that video. So if you want to, in addition to sort of like being here right now, look at that content. That's what I would recommend. The summer 2024 students also good, but I'm saying there were again a couple particular students that were really focused on some solid and helpful questions in that summer 2023 Stat 313 class. And so if you had to watch only one of those two videos, I'd say that one, the 2023, is the way to go. They
Yeah,
were
seems
using
like
the
a lot
same
of the
sample.
good information is similar.
I'm
Sorry, go
sorry, go ahead.
ahead.
No, you please.
Oh, yeah, just a pattern I've noticed is that most of the um more detailed information that you direct us to comes from the 2023 video. So,
Oh yeah, yeah. It's mostly because the students that term, again, had really in solid questions. And so naturally, asking those questions and the answers really is helpful. But they have the same sample exam as do you. And again, our exam starts in 45 minutes from now. I don't expect anyone's going to be taking it immediately, but if you want to, that's fine. And it is open until Friday at midnight. And I should say, in case someone is traveling, Friday midnight Pacific Daylight Savings Time. So make sure you have it done in time. And there's questions and answers. And so maybe the best way to tackle this is to go right into that document and assess any questions you might have on something in this document. So I don't know if you had a chance to look it over. If you did, that's wonderful. We could go over questions. But if you didn't, I'm happy to go through one by one, discuss each of those topics.
sorry, you cut out. Can you repeat that first part again?
Yeah. If you've got questions, we'll do whatever questions you have related to the sample exam. But if you don't, there are two choices. One of them is I could literally just go over the material in this sample exam and answer what I think are the typical questions students would ask. Okay. Or we can just say, you could watch that video from 2023 and that's fine too. Because I don't want to ruin it for you by sort of like showing you answers early on. If you would rather me not tell you that until you have a chance to look over the sample exam problems. So it's up to you. What do you want to do?
Is it okay if we go over review how you normally would, and then maybe just if you could
Yeah,
emphasize a little bit on interactions and the partial F test? I think I
yeah.
understand how to do the partial F test, but I still don't really fully understand its purpose.
Okay, great question. I'm going to sort of take that in mind and quickly look through that sample exam too, and for questions who relate to those two topics. Okay. And okay, so here's something related to an interaction, this second question, and you can even see it when comparing these two analyses. Okay. What do I got? I got pink. Pink's good enough. Let's go with pink. Notice that we've got this debt times population interaction in our analysis. There is an interaction here. So really the response variable is the amount of deforestation you have in these South American countries. Maybe what I should do is make this bigger so we can read it more easily. Zoom in, or is this zooming in? I think it's called zooming in, not zooming out. So what we have here is our countries in South America, okay? And there's 11 of them, and what we want to do is really assess whether deforestation happens differently in countries with a lot of debt versus countries with a small amount of debt. And the way deforestation is measured, it might be related to the country's population as well. Because, like, if it's like the amount of acres lost to deforestation in a large population country, there's more pressure on the ecosystem to provide wood, or, well, wood for construction or wood for firewood. And so we have this natural sort of way of thinking, yeah, more people, more deforestation would make sense. And so I'm going to fit a model where we've got both of these two explanatory variables in it. There's debt, okay, and population, both. Okay, and it looks as though both are statistically significant. Population is a little bit more highly significant with a p-value of about 0, but the p-value for debt is 0.001, and this is in an adjusted sums of squares, okay, context. Basically, you're thinking, yeah, controlling for the effective population, we see that there is a relationship between debt and deforestation. However, if we add the interaction in, we could actually do that by putting it in right there. And it does seem as though some things change a little bit. Here's where I want to mention whether you center your X variables when you interact them or not, it just doesn't matter at one level. JMP does center by default. This software package, Minitab, doesn't. Okay. And when you do center, the p-values for the other terms, the main effects terms like debt and population, should remain closer to constant. If you don't center, we would have the p-values perhaps changing dramatically. Like population, which had a p-value of about 0, becomes a p-value of 0.102. And the reason is we would interpret this p-value as, well, controlling for debt in the model. Maybe I'll check over here, and allowing for the population debt interaction to also impact the deforestation rate. Does population impact the rate of deforestation? Not so much. The reason is because debt times population is pretty darn correlated with the population itself. And so you already have in the debt times population interaction term, you already have some of the population impact. If you're controlling for that, you'd say population, it doesn't really matter all that much. It's like the legs. If you have the right leg length in your analysis already, does adding in left leg length as well help? Not much. Okay, so moving forward a little bit, um, let's tackle the questions. First off, why would you want to control for population when examining the relationship between debt and deforestation? Well, the real reason is population is related to the response. And if you don't control for population, you're less likely to understand the true relationship between debt and deforestation. Our results would be both biased and also less likely to be statistically significant. Controlling for other X's that matter help us spot whether the X of concern is related to the response Y. Okay, so the second question, what would the relationship do? Okay, how would the relationship between debt and deforestation change if you added a debt population interaction? I would say the relationship between debt and deforestation, it depends on the population. lower population countries and higher population countries will have different debt deforestation trend lines. That is the claim. So yeah, if the relationship between one X debt and Y deforestation depends on the level of the other X, you'd say you have an interaction or a need for an interaction, I should say. What about question C? Which of the two analyses would be preferred? Well, in a straightforward sense, the only difference between these two models is literally the additional term, and I have a p-value 0.113 for it. In our adjusted sums of squares, it's that right there, this p-value 0.113. Okay. So our two models are only different in terms of this new extra term. Do you need to keep the new extra term? With p-value 0.113, I'd say, nah, you don't need it. So which of the two analyses would be preferred? The one without the extra term, the interaction which is not even proving itself worthwhile. So any questions about that going through part C?
I think I'm okay so far.
Okay, so let me just note, we are set up right here to be able to do a partial F test for just the interaction term, debt and deforestation. So what I want to do is move this over here off to the side, and let's move it to the side, and let's talk about a partial F test. Okay, so in my partial F test, the null hypothesis, okay, is always that some of the terms in what you will say the complete model are zeroed out. Okay, so what are the reduced and the complete model? Let's talk about those. Our model is really that y, and I'm going to use a word equation here, is going to have like x1 plus x2 plus x1 times x2. Okay. If you will, the null hypothesis, we could write, actually, that's maybe it's right. That's a word equation. Let's write that out in terms of maybe a more formal model. Y is beta 0 in intercept plus beta 1 times x1 plus beta 2 times x2 plus I'm going to call beta 1, 2 times then the variable x1 times x2. So literally, you could view x1 times x2 as your interaction variable. The product of x1 and x2 is the new variable, if you will, that gets the new slope, beta 1, 2. And just because we like to do it, I'm going to write the plus epsilon because there's variability around the average trend line. Here is the average trend line. Anytime you have a partial F test, you're comparing a complete model with all of the terms to a reduced model where some of those terms are zeroed out. In this case, if I say beta 1, 2 is 0, that literally is a reduced model. I have eliminated the beta 1, 2 term. Yeah, literally I could say, let's say, cross that whole thing out. The reduced model, we're missing that one term entirely. Okay, so if my null hypothesis is that beta 1, 2 is 0, the alternative is that beta 1, 2 is non-zero. And so I'm thinking anytime you have a collection of some betas, but not all of them, that you want to zero out for a null hypothesis, that's a partial F-test context. So we could use the partial F-test here. So what we need for the partial F statistic is a collection of values. There's SS error for the reduced model and SS error for the complete model, SS error for the reduced model minus SS error for the complete model over the change in degrees of freedom between the two models. And we're going to divide that through by mean square error of the complete model. And fortunately, we have all the numbers lying around to identify those terms. Okay, we given the two models and we have the output. So what I want to do is to erase some of the content here
I have
and
a quick
then show you
question
where in the
before.
output to look for those. Yeah, please.
Yeah, just before we move on. Why is it, I'm not fully understanding why is it that we're what does it mean in the null hypothesis if we're the interaction term is equal to zero? What does that mean like for the model itself?
Oh, yeah, yeah. The slope of the interaction term being zero implies that the reduced model, yeah, the model with no interaction, is the correct model. If you zero out the interaction term, it says the impacts of population on deforestation and then debt on deforestation, they're, if you will, separate impacts. That the interaction not being there says the effect of debt on deforestation isn't different for the low population countries than it would be for the high population countries. The effect of debt is the same regardless of the population. So does that get to your question?
Yeah, that makes a lot more sense. Okay, the partial F test, I think I understand that better too now. So
Yeah, the interaction really boils down to is the relationship between this one x and y depending on a different x. And if always the same no matter what x, you'd say an additive model, a model without an interaction is sufficient. Okay, so what I did say is we have all the details we need to find our partial F test. And I'm going to try and circle them downstairs. Yeah, this is mini tab output here, but we do have a sum of squared error and we squared error. So let's figure out which one is the reduced model is always the model with few. Okay. So that 872 shoot. Then 9. Okay, I'm sorry. This is I might need to clean something here. Put the okay, there we go. Minus, okay. And I unfortunately 257 for 25, 7 closely, 07 something something. And I'm gonna need to erase that so I could see what the extra terms are. 07. I'm sorry, I entirely read the wrong line. So that's a good thing that I eliminated that. Boop, boom, come on. Okay, so there we go. Eliminate these things as well. And now I'm going to circle the correct thing downstairs, and that is for error. The sum of squares for error. That's 550, 20, 51. So that's the difference of the two model SS errors. And the difference in degrees of freedom, well, we had 8 degrees of freedom for error in the one model, and we have 7 degrees of freedom for the other. So that's a 1 degree of freedom difference between the two models. And we've got then mean square error for the complete model. So mean square error, MSE. And we're going to go with okay, so I would literally need to find mean square error because we've got the actually, so it is. Yeah, that would be fine. It's going to be the for the complete model, the adjusted mean square error. And here we go. Let's circle it. Okay, come on, circle. There we go. Divide through by the 7, 7, 8, 007. And I'm going to make a claim. The claim is that literally, if we were to do that whole thing, we're going to have, shoot, I'm going to have to look more carefully here. Something 0.27. I'm going to sort of like eliminate that and then write that this is 3.27. Now, I made that claim real quickly because I happen to know this is the F ratio for this individual term. The adjusted sums of squares, F ratio, if we were to eliminate exactly and only one variable, it could be done via partial F test, and it is the exact same results as if you had done the partial F test. So I know my answer already. And so you're maybe thinking, well, why did you do this? Well, I tried to leverage into this context an opportunity to revisit the partial F statistic and what to be in. That was my attempt to answer the two issues you raised within the context of this one problem. Do you want to follow up on any of this right now before I change gears and tackle the other parts in question two here?
Yeah, so in all cases, will the F statistic for the interaction term be the same as like if I were to have gone through this entire calculation?
I want to say yes so very badly, but I'm going to hold off on that because what if we had a more complex model with three explanatory variables, and then x1 times x2 is one interaction, and x2 times x3 is the second interaction. And if there were two interactions, I literally could drop both of those interactions with a partial F test. And if I were to do that, that would be giving different results than the adjusted sums of squares for each of those individual interaction terms. So I don't know that I answered your question, but I know that your question raised a really good issue, and I'm glad you asked it. So you want to follow up?
Yeah, I don't know. I still don't fully get it. What would it look like the calculations if it was more than one interaction?
Okay, so if it's really a partial F test, it means there's a more complex model, a complete model, and we're going to eliminate some of the terms from that larger complete model to get a reduced model. Okay, so let me see if there's another context in this sample exam where there's a situation which has a greater number of explanatory variables. Oh, look at this. There is a situation right here where, yeah, indeed, I have here again, maybe, okay, type treatment time, and then there is an interaction, yes. But in a situation where I've got three separate variables, type, treatment, and time, I don't even know what this was. Okay, so yeah, this is horse semen data. And I might want to ask a question like this. Test the hypothesis that time in no way has an impact on the response. Okay. What you're saying is time here by itself. Okay. You would say, let's zero that out. And then time interacted with type also would have to be zeroed out. If I'd say time has no relationship at all to the response, I'm saying the reduced model would be let's get rid of those two terms, both of them. Scratch them out. Okay. And so the null hypothesis is going to be you don't need either of those two terms. Maybe I'm going to move this down a little bit. Shoot, I just messed up my thing. Okay, so maybe clear all that. I'm going to write out the model here in its sort of fullest form. Okay. There is a time trend. Yeah. There's switched over to erase mode. Time trend. There is an effect of whether it's cooled or fresh. There's an effect of treatment or control. And then there's this interaction term. Okay. My model here is y on average is equal to beta 0 plus beta 1 times time. Plus, I'm going to go with alpha for cooled or alpha for fresh. Plus, then I'm going to go with just gamma for control, or gamma for the PAF chemical. Okay. And then we've got this time type interaction. Okay. And type is again cooled versus cooled versus fresh. So I'm going to call that alpha beta for well, the control, I guess the cool group, or there's alpha beta for the fresh group times then time. So here's a bit of information about the way I'm just sort of writing this out, the choice of symbols to use. Well, there's this slope, beta 1, times a quantitative variable. There's an effect, which we go with things like alpha or gamma. The effect would be of a categorical variable. And no, it's like, oh, there's this or that effect for cooled versus fresh. And then there's the treatment effect, either path group, okay? And so it's one of those two. But the interaction itself, the type time interaction, basically says there's an adjustment, an effect, if you will, on the slope. So that's why I put the beta in there for the cool group. So if you're in the cool group, there's an adjustment to the slope. But if you're in the fresh group, there's also to the slope, and it's going to be a little bit different. Okay. And it turns out that the sum of these two interaction effects is zero. So I guess if I tell you one of them, you know the other because you just change the sign. Okay, so the sum of the interaction effects has to be zero. You might have noticed that in our lab on chapter 7, the impact on the slope of income on prestige for the professional group, plus the impact on the slope for prestige for the blue collar group, plus the impact on the slope for the white collar group. The sum of those three impacts on the slope, the sum of those three adjustments to the slope, they sum to zero. But because they're slopes, they're multiplied by time. So if I'm basically saying, as my null hypothesis, do you need either of these? I'm really saying, could we drop both of them? The null hypothesis could be that the effect of the effect of I forgot what we erased. Okay, so beta, the null hypothesis is beta 1 is equal to 0, and alpha beta for the control group is 0. So in other words, there is no effective time, and the slope related to time also would be canceled out. That's your null hypothesis. If you're saying drop these two terms from the model entirely, the alternative is, well, not that. So at least one of those two things is non-zero, is my alternative hypothesis. Either there is a time trend. Let's pick a new color to go with that. Let's go with a green. Either beta 1 is not zero, or the effect on the slope of being in the cool group is non-zero. So either there is a slope on average, or at least one of the groups is different than the average slope. In other words, time has some effect on the response. Okay, so in a plain English way, it's sort of a little bit hard to wrap your head around it, but look for things like this. Hey, does this or that, do more than one variable get zeroed out or dropped? If we're comparing two models, if two models have more than just one variable dropped out of it to get the other model, you need to use a partial F test. So does that address your question?
Yes, very much. Thank you.
I love it. Yeah, and this is one of those things, summer class one, partial F test. We just learned about 2 days ago. and you haven't had the chance to sort of practice with it, my recommendation is to sort of do a little bit of prep work, especially the homework problems that are due tonight that include the partial F test, and then wait until the answers are posted at some point in time tomorrow, hopefully early in the day, and then you'll sort of have an additional resource, and then come by office hours tomorrow if you want to before you even start the test.
Yeah, I probably will do that. Sorry, a little bit off topic, but speaking of the homework,
Yeah,
do
yeah,
you know if those are going to be graded or are those part of our overall grade as
yeah,
well, or is it just the
yeah.
midterms?
The homework is definitely part of the grade, as are the labs. The labs always get full credit if you do them and turn them in, so that's a win. So like 1/6 of your grade or whatever the homework the lab is. I think it's about a sixth. That's always 100%, so that pulls scores up. Midterm scores are usually the lowest place, yeah, where our students do well because it's like a 50-minute timed exam. The final exam is like only a little bit longer, but you have twice as much time to do it. And so in that regard, students aren't rushed on the final exam compared to on a midterm. And then homework, well, homework does count, and it's because it counts that causes people to sort of focus on getting it done on time. But the on time is my trick of trying to get y'all to interact with the course material and ask good questions before it's too late. Yeah, so I'd say definitely do the homework first and wait until the answers are available tomorrow, and then maybe ask in office hours tomorrow about whether about those homework questions that are involving the interactions and then the partial F test. Yeah, the homework's exactly on the topics you're raising today. So good on you.
Okay, perfect. Thank you. I'll be sure to take a look at that.
Yeah, so let me sort of quickly see if there's any other highlights in terms of things that students typically wanted to know about or would benefit from knowing. And here's one of them. I don't know if I'm not going to sort of go into the details here, but on question one, uh, it's interesting that we have exactly four chimps learning 5 words. And we've got because of 4 word effects and 3 chimp effects, we've got 7 degrees of freedom for the model, 12 degrees of freedom for error. If I included an interaction between chimp and word, the fact that I have exactly one data point for each of the treatment combinations for each of the chimp word learning opportunities, you would have a perfect fit and 0 degrees of freedom for error. And so if you tried an interaction, the software would say, I'm sorry, I'm not doing that. Okay. Yeah, literally, we would always need at least 1 degree of freedom for error in the, or else you cannot do any of the hypothesis testing. Okay. That's one thing I want to mention. We sort of went through this pretty well. Question D in the debt and deforestation. In our term, it's going to be a little bit easier than when they took this exam. In our term, I'd say, oh, well, you just read the data right into GMP. And what you would do then is fit model and yeah, the profiler, the prediction profiler, literally you could drag the population to low like 3,000 or high to like 30,000, and you could see the impact on the slope. So you could quickly answer question D using tools of this term. But I believe the sample exam answers sort of walk you through it. What if you didn't have that prediction profiler? And then for part E, what if you had a categorical variable, tropical or non-tropical, because there's very different countries in South and Central America, and a whole bunch of them, they grow wood quickly, and in some of them, they don't grow wood quickly. Chile and Argentina, not tropical at all. And so if you wanted to include tropical or not in the relationship as a categorical factor, you just add that in via your analysis. Okay. Okay. And we talked about this a little bit. Uh, I think I'm happy with that. Yeah. Okay. So that is a set of questions about as long as our exam will be. And I'm happy to sort of answer any extra questions you might have, or you could refer to the other videos from past terms.
Yeah, that was really great information. Thank you.
Cool. So what I'm going to do is stop the share now, and I'm going to stop the recording now unless you tell me not to.